Okay, so section 11.3, we're still going to be solving quadratic equations, but this time we're going to do it using the quadratic formula. And so this is something that will always work as long as you have your equation in the correct form. So this is kind of the fallback option when you cannot factor, you can't use the square root property, and you probably just don't want to use completing the square because that one's just kind of a more difficult method for solving. So let's list out what we have so far. So like I just said, we have the first go-to method for solving quadratic equations should be factoring when possible. Usually that's the fastest way of solving a quadratic equation. Second method we've talked about is the square root property. And so remember with the square root property, this was when you had something of the form x squared equals a, and you would square root both sides. You could also have something where you have, let's say, a quantity being squared. So I just put b in there to represent a number, but as long as you have some term or some quantity being squared, that is the key thing, and just a number on the right. As long as it's a number on the right, not another variable, you can use the square root property. Thirdly, we went through completing the square. Again, that method just isn't super nice, but you will use it in Math 126. So you do want to know how to do it. Now, let's go ahead and look at the quadratic formula. And hopefully this is something you've seen before in a previous math class. So you may have it down, you may not. The quadratic formula, we're going to have x equals negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Now, there is a kind of song that goes along with this. I think it's maybe Pop Goes the Weasel. I can't remember. I just kind of sing it in my head in that tune as I write it down. It's just kind of habit now. So I would definitely recommend looking that up. You can just look up quadratic formula song and it should pop up. There's also a story that goes along with this, and I don't remember exactly what that is. But if you look up ways to remember the quadratic formula, because you're going to want this memorized, there should be a bunch of different ways to kind of get it down. But this is really important. So I'm going to put some stars around this. Make sure you get this down. If you're curious about how we even come up with this, it actually comes from the standard form of an equation. So ax squared plus bx plus c equals 0. And what they've basically done to get all of this is they go through and do completing the square on this equation with these variables, and you end up with this. So that's kind of how you get to this, and there's an entire derivation of that in the book if you're curious in this section, but we're not going to go through it here. So one more thing before we look at some examples. The equation that you're working with when you're using the quadratic formula must be in standard form. So standard form is this right here. The reason why it has to be in this form is that A, B, and C come from this A, B, and C. C is always the constant. A is in front of the x squared, and B is in front of the x. If it's not in standard form, then your signs could be wrong. Let's say the C was actually over on the right. It would have the opposite sign. So you want everything on the left, all multiplied out, 3 distinct terms. Sometimes you'll only have 2. Most of the time you'll be working with all 3 terms though. Okay, so let's go ahead and look at some examples. So for these examples, we're told to solve using the quadratic formula. And so this first one here, we're given x squared minus 8x minus 48 equals 0. So first thing we want to check is if this is in standard form, which it is. We have x squared, the x, and then the constant all on the left. Now, this is one that you would actually be able to solve using factoring, and this one would factor pretty nicely. But let's go ahead and use the quadratic formula to see kind of how this is going to work. So first thing I'm going to do is list out what A, B, and C are, and if you want to do this, you can, especially in the beginning. You don't have to, though. So A is the number in front of our x squared. You don't see one, so it's a 1. B is negative 8. Make sure you bring the sign. And C is negative 48. Now, when we plug this in, we're going to have x equals, I'm going to rewrite the formula up here. And notice how it's x equals, because this is our solution for x. We get negative b plus or minus the square root of b squared minus 4ac all over 2a. So first things first, we're going to have the opposite of b. So it's always going to be the opposite of what your b is. So ours is negative 8, so it'll be positive 8 plus or minus the square root of b squared. Now always make sure you put this in parentheses or square it straight away. But I'm going to break this down into all the little steps. Minus 4 times a, which is 1, times c, which is negative 48, all over 2 times a, which is 1. Now, what you want to do first is simplify the inside of the radical. So I'm going to leave this 8 plus or minus, and now on the inside, because this square term and this multiplication are kind of 2 separate terms that we'll be combining, we can do it at the same time. So negative 8 times negative 8 is 64. And now if we look at our next set of terms here, we have 4, 1, and negative 48. I'm actually going to treat this 4 as a negative 4, because then we'll have a negative times a negative, which is a positive. So I'll put a plus. And then 4 times 48, just kind of skipping over that 1 because it won't change anything. 48 doubled is 96. And then 96, if we multiply that by 2, whoops. Because multiplying by 4, you can double the number and then double it again. We get 192. Now, that's in our square root still. On the bottom, 2 times 1 is 2. Let's keep simplifying inside the radical. So we have 8 plus or minus. Now the square root of 64 plus 192, you have to add these before you take the square root. So if we add 192 and 64, we're going to get 256. Whoops, still inside the square root. All over 2. And now sometimes you'll end up with numbers that are pretty nice. Sometimes you'll end up with ones that are not perfect squares and you have to just kind of simplify it down. 256 is a perfect square. It's one of those that's a little bit bigger. So you don't see it a whole lot, but the square root of 256, if we were to go ahead and you can kind of test numbers to see what that would give you, if you multiply 16 times 16, then we get 256. That's the way you can kind of check your square roots when you're not sure and you don't have a calculator. Just kind of multiply numbers together like I did. So that means the square root of 256 is 16. So we have 8 plus or minus 16 over 2. Now, this is the part where you'll either have to reduce something, get two distinct answers like we'll have here, or just kind of leave it as is. Sometimes you can simplify, sometimes you can't. What we have here actually is two distinct answers. We have 8 plus 16 over 2 and 8 minus 16 over 2. So 8 plus 16 over 2, 8 plus 16 is 24, and 24 over 2 is 12. And our other answer over here, 8 minus 16 is negative 8. Actually, let me put this over here, over 2, and negative 8 over 2 is negative 4. Reduce your fractions all the way down, or in this case, just divide. Okay, now let's go ahead and take a look at another one where the answers might not be quite as nice. Number 2, we're given 15x squared minus 2x minus 8 equals 0. So again, I'm going to write out A, B, and C. A is 15. B is negative 2. C is negative 8. So we're going to have x equals the opposite of b, so positive 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 15, times c, which is negative 8, all over 2 times a, which is 2 times 15. Now let's go ahead and simplify. So we're going to leave that 2 plus or minus. And on the inside here, negative 2 squared is 4. Again, I'm going to look at the signs. We have a negative times a negative is a positive, so plus. And multiplying a positive times a positive doesn't change it. Multiplying by a positive is never going to change the sign of our number. So I'm just going to count the negatives that we have. So 4 times 15 is 60. 60 times 8 is 480. All over 30. And now, if we go ahead and add those two numbers together on the inside, we get 2 plus or minus the square root of 484 over 30. Now, if we go ahead and let me pause for a second. Okay, sorry, I paused my recording because I realized I didn't mean to include this problem in here, but we're basically done. So let's just continue along with this one. Okay, so look at the square root on the inside. Kind of hard to tell right now if it's a perfect square or not. So I'm going to try multiplying some numbers kind of around what I think this should be to see if we can get a perfect square root or if we need to simplify. So I know 20 times 20, that's a pretty nice one, is going to be 400. So that's pretty close. And this ends in a 4. So if we did 21 times 21, multiplying just the ones place, 1 times 1 would give us a 1 here. That's one nice way to kind of check these. If we did 22 times 22, that could work because 2 times 2 is 4. So let's try multiplying 22 times 22. So we get 4, 4, bring a 0, 4, 4, and we get 484. So the square root of 484 is 22, so we have 2 plus or minus 22 over 30. Let me erase all of this stuff down here. And if we go ahead and get our two separate answers, we're going to have 2 plus 22 over 30, which would be 24 over 30. And all we can do here is reduce. So we get, these are both divisible by 6. So we get 4/5 as one solution. So fractions are completely acceptable. And then if we subtract, so 2 minus 22 over 30, that would be a negative 20 over 30. Reduce that, we get negative 2/3. All right, so that's another one where, because we got rational answers here, it might have actually been factorable, but in order to factor this, we would have had to do 15 times 8. That itself is pretty big. That's going to be a pretty big number to work with. And so you'd have to find two numbers that multiply to that, add up to -2. And it's sometimes a little bit easier if you just go through and use the quadratic formula, depending on how you feel about this. But there are some times when we have to use it. So let's go ahead and look at another example. So for this one, we're given 2x squared plus 8x plus 7 equals 0. So again, it's in standard form. So I'll list out A, B, and C. A is 2, B is 8, C is 7. Now, if we go through and plug in, we have x equals the opposite of b. So this time it's -8 plus or minus the square root of b squared, so 8 squared. I left the parentheses off because it's positive, but again, always a good idea to just kind of leave parentheses there so that you don't forget them when you're working with negatives. -4 times a, which is 2, times c, which is 7, and then all over 2 times a, which is 2. So simplifying a little bit, we'll leave that -8 plus or minus. Now 8 squared is 64, and we have a minus. There are no other negatives, which means this is going to be a negative. 4 times 2 is 8. 8 times 7 is 56. All over 2 times 2 is 4. Now, if we go ahead and simplify, we have -8 plus or minus the square root of 64 minus 56 is 8, all over 4. Now, square root of 8 isn't something we can actually take the square root of and get a nice whole number, but we can simplify it down. So we're going to have -8 plus or minus. Now, the square root of 8, we can write this as 4 times 2. So, and actually, let me do this. I was going to do it in a separate, do it up here, but we'll do it right in the equation here. So I'll break this into 4 times 2. Square root of 4 is 2. So let's take out a 2. And now you have to make sure that number, when you take it out, goes right in the front of the radical. So we're going to have -8 plus or minus 2 square root of 2 over 4. And now this is one of those simplifying problems that we saw at the end of, I believe it was 10.5. Now I showed you two different ways to simplify. You can factor out on the top and then reduce, or reduce as is. Now, if you're reducing as is, which is what I'm going to do, you want to make sure that you're reducing from all 3 terms. And make sure you only reduce with the numbers outside of the radical. You won't be able to simplify with the numbers in the radical, but I can reduce 8, 2, and 4 by 2. So -8 divided by 2 is -4. 2 divided by 2 is 1. 4 divided by 2 is 2. So we get -4 plus or minus 1 square root of 2, which is just square root of 2, all over 2. And when you're typing these into my math lab, I can't remember if they have a plus or minus. If they don't, just make sure you split it up into the two answers. So you would have -4 plus the square root of 2 over 2, and -4 minus the square root of 2 all over 2. And just make sure you're putting the fraction all over 2. Make sure it's not just the square root over 2, it's the entire thing. Okay, let's try another one. So that was one of the cases where it's simplified. We just can't get the radical all the way down. Now let's go ahead and try one where it's not quite in the form we want it to be in. So we're given 2x squared minus 7 equals 2x. Now with this one, it's not in standard form, it's not equal to 0. So first thing I'm going to do is move this 2x over to the other side. So I'll subtract it and make sure it goes in the right place. So it is our middle term, so I'm going to have 2x squared minus 2x and then minus 7 equals 0. Now it's in standard form, so we can get a, b, and c. And so a is 2, b is -2, c is -7. And now we can go ahead and do our quadratic formula. So we have x equals the opposite of b, so +2 plus or minus the square root of b squared, so -2 squared, minus 4 times a, which is 2, times c, which is -7, all over 2 times a, which is 2. So now simplifying, let's look at the inside of the radical. -2 squared is 4. And then we have a negative and a negative. That'll make a positive. 4 times 2 is 8. 8 times 7 is 56. All over 2 times 2, which is 4. Now we have 2 plus or minus the square root of 60. Let's combine those over 4. And now we're at the point where we want to simplify our radical down. Don't reduce yet because the 60 is under a square root. So let's see what perfect square goes into 60. We have 1 and 60, 2 and 30, 3 and 20, and I'm going to stop once I get to a perfect square. 4 and 15. Now, I'm actually not going to stop on this perfect square. Had the perfect square been on the right side, I would have stopped because the right side has the larger perfect squares. If I keep going a little bit, we're going to have, let me underline this one. We're going to have 5 and 12, 6 and 10, and then 7, 8, and 9 don't go into it. So 4 and 15 are the only perfect squares here. So we're going to break that 60 into 4 times 15 all over 4. Now take out the square root of 4, make sure it goes right in front of the radical. So 2 plus or minus 2 square root of 15 all over 4. Now, this one you do want to be really careful when you're reducing this down. Notice how I can divide this 2, 2, and 4 by 2. Now, one really common mistake here is just getting rid of this first term because 2 divided by 2 is 1, so it's gone, but it's not gone, it's a 1. Make sure when you're reducing, you actually put that 1 there. For the second one, it doesn't actually matter because 1 times any number is still that number, but adding or subtracting 1 is going to change a number. So include the 1 in the front. You don't necessarily have to include this one. If you want to include the second one here, just so you're in the habit of keeping it, go for it. And then on the bottom, 4 divided by 2 is 2. So now finally, we're going to have 1 plus or minus 1 square root of 15 all over 2. Now, normally I'll just leave my answers like this. Again, if you wanted to split them up for my math lab, it'll be 1 plus the square root of 15 over 2 and 1 minus the square root of 15 over 2. All right, let's go ahead and try a few more of these. Now, these next ones are ones that I want to show you guys because they give you something that is not in standard form. Now, if we look back at what we had in this one in number 4, it wasn't in standard form, so we moved that term over to the left. But if we look at this one, oops, we're given r minus 3 times r minus 7 equals negative 5. Now, with this one, we are not even close to being in standard form. We have some things being multiplied on the left, something on the right, it should be 0. So first thing you want to do, if you have something like this, and you'll also see one where you have, just as an example, you'll see something like this in your homework. You want to make sure you distribute. That's how you're going to get your k squared or your x squared. And then you're going to move everything on the right over to the left. So let's do something similar here. We're going to FOIL this out. So we get r times r is r squared. R times negative 7 is negative 7r. Negative 3 times r is negative 3r. And then negative 3 times negative 7 is a positive 21 equals negative 5. Now let's combine. We get r squared minus 10r plus 21 equals negative 5. And we are almost in standard form. The r squared and the r are good, but we want to make sure it's equal to 0. So let's add 5 to both sides. So we have r squared minus 10r plus 26 equals 0. Now we can go ahead and go through with the quadratic formula. A is 1, B is negative 10, C is 26. So this time it's an r instead of an x, so I'm going to say r equals negative b, or the opposite of b, so 10 plus or minus the square root of b squared, so negative 10 squared, minus 4 times a, which is 1, times c, which is 26, all over 2 times a, which is 1. Okay, now let's go ahead and simplify here. I'll actually do this over here. 10 plus or minus, now negative 10 squared is 100. Negative, we have a negative 4, that's the only negative, so this will be minus. 4 times 26, 26 doubled is 52, 52 doubled is 104, all over 2. And then we get 10 plus or minus, now 100 minus 104 is negative 4. So big thing here is that because we have a negative, this is imaginary. So this is what we saw in section 10.7. So we're going to go ahead and simplify this. So remember, if there's a square root of a negative, you'll take the negative out as an I, and the square root of 4 is 2. So this is 2I, so 10 plus or minus 2I all over 2. And now this one, notice how we can take the 10 and the 2 and divide both of them by 2. Now if we do that, if I reduce everything by 2, 10 divided by 2 is 5. 2 divided by 2 is 1. 2 divided by 2 is 1. If we have some number over 1, that doesn't change that number. So we're just going to go ahead and write this as 5 plus or minus 1I, which is just I. You don't need to put the over 1 because putting something over 1 doesn't change the value. And again, if you were to split this up, it becomes 5 plus I and 5 minus I. Okay, let's go ahead and try one more with some imaginary numbers, and then we'll move on to the last part of this section. So we're given x squared minus x plus 4 equals 0. Now at this point, we've done quite a few of these, so I would actually try doing this one yourself. This one will end up with imaginary numbers, so keep that in mind. So we have A, B, and C. A is 1, B is -1, C is 4. So we get x equals the opposite of B, so +1, plus or minus the square root of B squared, so -1 squared, minus 4 times A, so times 1, times C, so 4, and then all over 2 times 1. Now, simplifying a little bit, we have 1 plus or minus the square root of -1 squared is 1. Now we have a single negative, so it'll be minus 4 times 4 is 16, ignoring that other 1 there, all over 2. Now, if we look on the inside here, 1 minus 16 is -15. So because that's a negative in there, that's another indicator that this is going to be imaginary. But 15 isn't something we can break into a perfect square times another number. So all we're going to do, and you want to make sure you do this, is take out the negative as an I and leave that 15 on the inside. And so this is as far as we can go with this one because nothing can be reduced and the 15 can't be simplified down. And again, you could write this as 1 plus I square root of 15 all over 2 and 1 minus I square root of 15 all over 2. So that is using the quadratic equation. The last part of this section talks about the discriminant. And so the discriminant is the part under the radical, so the b squared minus 4ac. And this is going to tell us how many and what type of solutions we have. So the discriminant is b squared minus 4ac. This tells us how many and what type of solutions we have. So I put solution and then in parentheses solutions because you can have one solution. We didn't actually see a case like that, but we'll discuss that a little bit. So let's go ahead and I'm actually going to write out a chart. And so in this chart, we're going to have the discriminant on the left. So remember, this is b squared minus 4ac. And then on the right side, we're going to have the solutions. All right, so over here on the left, we're going to have 4 different cases. The first case is that if the discriminant is positive and a perfect square. So for this one, think back to our first example. Here we had so we're looking at the inside of the radical. We had a positive perfect square, and we ended up with 2 integer solutions. So over here in the solutions, we're going to have 2 rational solutions. And that could be either, well, they're always going to be rational. Just remember that they could also be fractions. They don't have to be whole numbers like we got here. If we look down here, we also had a perfect square under the radical, but we ended up with 2 fractions, which are still rational because they're fractions. So if we look at our next case, the next case is if we have a positive non-perfect square. Now, for a positive non-perfect square, let's see one of our examples here. Like in number 3, we had 8 under the radical, which is positive, but it is not a perfect square. And so when we simplified this all down, we ended up with this answer right here. And now this is irrational. Because of the square root of 2, if we don't have the square root of a perfect square, it gives us an irrational solution, but we still have 2 of them because we have the plus and the minus. We got 2 solutions. So we're going to have 2 irrational solutions. Number 3 is if our discriminant is 0. Now, this is the one that we did not see, so let me just write out a quick little example here. So let's say we had 4 plus or minus the square root of 0 over 2. Now, the square root of 0 is 0, so this is the same thing as 4 plus or minus 0 over 2. But if we add 0 and subtract 0, we get the exact same number. So because we get the same number when we add or subtract 0, we really only have one solution here, 4 over 2. And it's still rational because we don't have the square root of a negative number or a non-perfect square. So we get one rational solution. And this is the way, if you saw this on a test, where you can kind of think about it. So write yourself up a situation where you have 0 under the radical, or in number 2, you have a non-perfect square. So I could have put like a 10 under the radical. Just kind of test them out. Because then our last one is if we have a negative number under the square root. Now, this can be negative perfect square or non-perfect square, because in both of those cases, if we have a negative under the radical, so let's say we had 4 plus or minus the square root of negative 20 over 2, what does a negative number indicate? That indicates that we have an imaginary solution. And we're going to have 2 of them because we're going to add and subtract it. So we'll have 2 non-real, and remember that just means imaginary, complex solutions. And complex just means, if you remember from 10.7, complex number was in the form a plus bi. So you have some real part and then some imaginary part. All right, now let's go ahead and look at some examples. And all we're going to do is we're going to say if these solutions are, well, what kind of solutions we have, how many we have based on the discriminant. So we're not actually going to solve these. There's one more thing we're told to do though. So for these examples, we're first told to find the discriminant. And then we're going to use it to give the number and type of solutions. It looks like not the right word. There we go. Number and type of solutions. And so for our practice now, we'll refer back to the chart. Then we are going to tell whether we should use the zero factor property. So remember, zero factor property just means factoring. Or the quadratic formula to solve. But specifically, we are told do not solve these. So we're going to go through and you'll be given the 4 different options for the number and type of solutions, but we're just going to look back at the chart. Number 1 here, we're given 2x squared plus 3x equals 4. And now first thing here, what we want to do is make sure it's in standard form in order to use the discriminant. So let's move this 4 over to the left. And let me write that up here. It must be in standard form. So we get 2x squared plus 3x minus 4 equals 0. Now, if we find the discriminant, we're going to have b squared minus 4ac. B is 3. A is 2, and C is negative 4. So we're going to have b squared, so 3 squared, minus 4 times A, which is 2, times C, which is negative 4. Now we have 3 squared, which is 9. Negative and a negative make a positive. 4 times 2 is 8. 8 times 4 is 32. Now, if I add these together, we get 41. So imagine this being on the inside of the square root. We have everything else here. We have stuff on the bottom of the fraction, but this 41 is inside that radical. Now, let me box this. This is our discriminant. That's part of our answer. Because this is it's a positive non-perfect square, because of this, this means if we go back here, we're going to have 2 irrational solutions because we won't be able to take the square root of 41, but it is positive, so they will be real. So we're going to have 2 irrational solutions. And now we also want to say if we should use the quadratic formula or the zero factor property. First thing we want to do here is just figure out if we can factor this. So if we use the big X, let me actually, we'll do it down here. So we're going to multiply to 2 times negative 4, which is negative 8, add to 3. Well, everything that multiplies to negative 8 is 1 and 8, 2 and 4. There's no way if I make one of these positive and one of them negative to get a 3. So it's not factorable. So because it's not factorable, we're going to use the quadratic formula. And so that's the kind of process you should be taking when you solve one of these equations, because you're not necessarily, depending on the problem, you're not necessarily going to be told how to solve it. So you're going to want to check for factoring. If that doesn't work, use the quadratic formula, as long as it's not set up to use the square root property. All right, let's try a couple more of these. Number 2 here, we're given 2x squared plus 3x plus 4 equals 0. So again, first things first, let's find the discriminant. B squared minus 4ac. A is 2, B is 3, C is 4. It's in standard form. So b squared is 3 squared minus 4 times A is 2 times C, which is 4. Now 3 squared is 9. We only have one negative, so it'll be minus, and it's the exact same number as before, so 32. And now 9 minus 32, this is going to give us a negative 23. Because this is, because this is negative, think about there being a negative 23, negative 23 inside of that radical. Whatever else is here, but a negative in there means that we're going to have two, I'm just going to write 2 imaginary or non-real complex solutions. And if we were going to look at how we should solve this, if we try to factor, we're multiplying to a positive 8, adding to 3. Well, again, we have 1 and 8, 2 and 4. None of those add up to 3, so we want to use the quadratic formula because we cannot factor. All right, and then let's go ahead and look at this number 3 here. We're given x squared plus 20x plus 100 equals 0. Again, it's in standard form, so let's find A, B, and C. A is 1, B is 20, C is 100. And if we find our discriminant, it's a 4ac. B squared, we have 20 squared minus 4 times A is 1, C is 100. And simplifying this, we have 20 squared is 400. Now minus another 400. This is 0. Now, if we had a plus or minus the square root of 0 at the end of our quadratic formula on the top, that tells us that we're only going to have one solution because adding and subtracting 0 is exactly the same. So we're going to have one rational solution. And if we take a look and see if we can factor here, we're going to be multiplying to 100, adding up to 20. That is possible. We can do 10 times 10. So we're not actually going to factor here. We're just going to say that we'll use the 0 factor property. Okay, and I do want to squeeze this one last one on here because this is our other case. This one we're given 15x squared minus 14 equals negative 11x. First thing to do here actually is make sure it's in standard form. So if we go ahead and add this 11x over to the middle here, we get 15x squared plus 11x minus 14 equals 0. Now let's go ahead and find A, B, and C, so we can find the discriminant. So it's 15, 11, and negative 14. So we have B squared minus 4AC. B squared, we're going to have 11 squared minus 4 times A, which is 15, times C, which is negative 14. Now, these numbers are a little bit bigger, so sometimes you might have to do some multiplication off to the side. 11 squared is 121. We have two negatives, which make a positive. Now, 4 times 15 is 60. 60 times 14, we're going to have, just multiply this one out, 840. And now, if I add those two together, we get 961. Now, I have no idea if this is a perfect square or if it is not a perfect square. It is positive, so we should have we should have real solutions, not non-real complex. So what I'm going to do is I'm going to kind of test out some numbers. I know 30 times 30 is 900. That's pretty close. This ends in a 1, so I'm going to try 31 times 31. So we get 1, 3, add a 0, 3, 9, and we get 961. So this is a perfect square, which means thinking back to our chart and thinking about the fact that we would have 961, which is equal to 31 when you take the square root. This is going to give us two rational solutions. That's because this is a perfect square. And then let's tackle the factoring on this one. Let's see if we can factor this. So we need to find two numbers that multiply 2. Now this is really big. We have 15 times 14. So if we go ahead and multiply these together, we get 20, that'll be a 6. Then we got a 5 and a 1. This is going to be 210 negative. And oops, we want to find two numbers that multiply to 210 and add up to 11. Now, one thing you can kind of do here is go through and do like 1 times 210, 2 times 105, just taking half of it, 3 and 70, that one's pretty nice. 4 doesn't go into it because when 2 goes into it, it goes in an odd number of times, so that's how you can kind of check for 4. These numbers are still pretty far apart though, because one is positive, one's negative. They should have a difference of 11. Let's try something a little bit bigger. One thing I notice is that 10 goes into it. 10 goes into it 21 times. Now, these ones are 11 apart, so we're going to have a negative 10 and a positive 21. This is going to be factorable, which means we're going to use the zero factor property. So that is one where personally, well, now it kind of depends. If we went through and did all that work and figured out that it was factorable and we have our two numbers, it's really nice. If you see those numbers and you don't want to factor, you can just use the quadratic formula. Just know with the quadratic formula, you're also going to have to deal with big numbers under the radical. So there's kind of that trade-off where if you don't want to deal with the big numbers here, when you're factoring, you will have to deal with them over here and they could be even bigger. It just kind of depends. It also depends on the sign of the numbers. So in general, what I like to say is if it's factorable, factor it. If it's not, quadratic formula. All right, and that's it for 11.3. Next, we'll be seeing 11.5. For this wintermester class, we do skip 11.4. 11.4 is the, it's more quadratic equation solving, but you're going to see kind of a little bit of review from like rational expressions, stuff like that. Those are pretty tough, and we do get to skip those in this class. We'll be looking at 11.5, which is some word problems with quadratic equations.